Hello everybody, welcome to today's video on acknowledgement delays. The first thing we're going to talk about is what is an acknowledgement delay. When an AES subscriber sends out a signal, it waits for an acknowledgement or an ACK from its peer before it considers that signal sent. If the subscriber does not receive the ACK, it will continue sending messages until it's able to get a peer, another AES subscriber, to respond to the radio message being sent. If a subscriber does not receive the ACK, it will continue to increase radio traffic on your network because it will have to try additional peers. This will make your network not work as efficiently as possible. Now let's take a second and talk about what causes Ack delays. Ultimately, Ack delays are communication issues that could be one of three main possibilities. 1. There's no AES radio network in your area. Couple things to check. Can you get a signal in the parking lot? Can you get a signal in the room where you're installing your AES subscriber? The second option is there's too much interference in the area where the antenna is located. Is there any metal near the antenna? Ideally, we'd have no metal within 18 inches of the antenna and above the ground plane. Are you in a metal building or in the middle of a large building? If you're in a steel structure or a concrete structure, even the concrete has rebar. Electricity can also create radio frequency interference, or RFI. Is the AES subscriber near anything that draws large amounts of electricity? Large amounts of electricity will interfere with your radio signal. The third possibility could be an installation issue. Is the coax cable between the antenna and the AES subscriber as short as possible? The less cable, the greater the signal strength. If you're using a rubber duck antenna, confirm that the nut below the antenna is tightened with a wrench. It needs to be tighter than finger tight. This will help ground the antenna. Are the ground planes installed correctly? The only AES antenna that does not require ground planes is the stealth antenna. Is there an issue with the connectors or cable? We recommend using a bird wattmeter to test the forward and reverse power to see if you have any issues with your connector or cabling. For outdoor antenna installs, is the antenna above the building roof line? Is the antenna on the exterior wall in the direction of your AES radio mesh network? As you can see here, this crimp is not going to allow radio signal to pass through it. Now let's talk a little bit about selecting the correct antenna. One of the most important parts of selecting the proper antenna for your AES installation is to consider the beam width of the antenna. Now with our rubber duck antenna, that's a unity gain antenna, that will send the signal 360 degrees in all different directions. As we move up to our higher dB antennas, what those antennas will do is it will focus all that 2 watts of energy that comes out of the AES transceiver, and it will focus it into a 35-degree beam width. So instead of sending it 360 degrees, it's only sending it 35 degrees for a 3 dB antenna, and 7 degrees for our highest dB antenna. Let's see how this can affect us in a real-life example. But this is the beam width coming off of these antennas, and as you can see, there's no overlap. And if there's no overlap, they will not be able to acknowledge each other reliably. Even if these antennas have line of sight with each other, they will not be able to communicate because of the mismatch in antenna beam width. Here you can see where the subscriber's antenna beam width will overlap, so these two subscribers should be able to see each other and acknowledge each other with no problem. The two biggest factors are the beam width of the antenna and the height of those antennas when selecting the proper AES antenna to install. Let's talk about how to test for an acknowledgement. These are going to be the lights found on the board of the AES subscriber. If you want to initiate a transmission, please hit the reset button on the board of the subscriber. After you do that, the TX light will show up. This will go out when the transmission is done sending. Then the RX and the WA light will light up. And how long it takes for the WA light to go on and off is how long it takes for the radio signal to get to your nearest peer and get the acknowledgement back. This way we can confirm we have good two-way communication with our nearest peer. In programming, you can extend the amount of time that AES subscriber will wait for the acknowledgement. The default time is going to be 60 seconds, and the setting is under Radio Configurations and Communication Timeout. You can extend this for up to 300 seconds. Generally, however, the AES subscriber is not the limiting factor. If you're using the IntelliPro to connect to the alarm panel DACT, then the Ack must be received before the alarm panel ends the phone call. If you can extend the amount of time the alarm panel waits, this can definitely help with Ack Delay issues. For our legacy subscribers, it is also called COM Timeout, and this will be available if you connect the handheld programmer, hit Control F2. As with the 2.0 subscribers, if you're using the IntelliPro, a lot of the times the AES subscriber is not the limiting factor. You must get the acknowledgement back before the alarm panel hangs up the call with the AES subscriber. Let's go over a few things that we can double check before having to move the location of the AES antenna. First, we want to make sure we have AES radio mesh in the area. You can check it in the parking lot, check it in various locations in the building. Which direction is your nearest subscriber? If you're able to figure out where your nearest peer is going to be, that could help you find a location that works. Confirm the antenna installation has ground planes installed. This will greatly increase the signal strength. We also want to make sure that the antenna is grounded. Make sure to tighten that nut for any antennas that are installed in the top of the subscriber can. And make sure that your antennas are grounded if they're mounted up on a mast. Keep the coax cable as short as possible and not tightly coiled. Tightly coiled coax will also reduce your signal strength. Please also make sure you're following the maximum cable lengths. 25 feet for RG58, 75 feet for RG8, 125 feet for LMR 400. Also, let's test the connectors and the cable using a Bird watt meter. If all of those check out, then what we can do is look to a couple of other options. We have our AES extender, which acts like a wireless antenna. It eliminates the need to run long cables when getting the signal outside the building proves challenging. Try moving the antenna to a different location in a room or building. Confirm the subscriber will get a netcon in 5 minutes and the WA light goes on and off within 5 or 10 seconds. You can also mount higher quality antennas to the top of the subscriber can. AES recommends the Phantom antenna. This is our highest quality antenna and is the best chance of getting the AES signal out of the room without installing a remote antenna. These are suggestions we'd recommend. For any additional information on these products, please check our website at aes-corp.com, leave a comment, or contact us at support. Thank you very much, and I hope you have a great day.